Okay, this video is our first lesson on factoring. We're going to cover factoring polynomials, some with just the greatest common factor, and some that require factoring completely beyond the greatest common factor. First, we're going to look at factoring out just the greatest common factor. That's the largest number that will divide into each term without remainder, and it's also the variable or variables that is common to each term, and you always use the variable that has the smallest exponent. So for instance, in the binomial we have here, I'm going to look for a number that might divide into both of these terms. I notice that the coefficient on the first term is 1 and the coefficient on the second term is 3. And the greatest common factor between those two numbers is 1, so we don't have to divide a number out of the term. So the next thing I look at is the variable part. Do they both have an a? This one has an a, and this term also has an a. And of these two variables, the two a's, the lowest exponent on them is 1. They both happen to be the same. So part of our GCF is going to be a. Secondly, I look at the x. This has an x squared, this has an x cubed, so the one that I'm going to take for my greatest common factor is x squared. Now to factor that out, I'm just going to divide each term by ax squared. Now when writing my final answer, I have to put the greatest common factor on the outside. And now when I do ax squared divided by ax squared, I get a quotient of 1. And then when I do 3ax to the third divided by a squared. Alright, so here I've got a couple more examples to factor out the greatest common factor. In my first example, the GCF, remember I look first at my numbers. I've got a 2 and a negative 8, and so the biggest number that will go into both is 2. And then I notice that both of the terms have an m being the lowest exponent between m and m squared. So m is part of my greatest common factor. And I also notice that they each have a y, and they're the same exponent, so I'm going to go with just y. So I'm going to take my greatest common factor and divide it into each of these terms. So I'm going to write my answer with the greatest common factor on the outside of the parentheses. And when I divide 2my divided by 2my, I get 1. And then I have negative 8 divided by 2, which gives me negative 4. M squared over m leaves me with m. And then my y's, y divided by y is 1, so I don't write anything for my y's. Now looking at the second example, I have a GCF. I look at the three numbers, a 7, a negative 14, and a 21. And keep in mind that your GCF can never be larger than the smallest number that you have. So try the smallest number. Just if 7 goes into the other two, then that's your greatest common factor. And that's the case for this one. 7 divides evenly into all three. All three terms do not have an a, because the middle term does not. So a is not part of our greatest common factor. All three terms do, however, have a b. And b is the lowest exponent that there is. 1 is the lowest exponent that there is. So b is a part of my greatest common factor. Now I take that and I divide each term by that greatest common factor. So my final factored form answer, I'll write the GCF, and then I do my division. So 7ab divided by 7b leaves me with just a. Negative 14 divided by 7 gives me negative 2, and my b's in this case are gone because b divided by b is 1. Then we have positive 21 divided by positive 7, which gives me positive 3. And I'll have an a squared left for that positive 3. And so the factored form of this trinomial is this right here. Okay, next we're going to take a look at some special patterns when we're factoring, because this can save you some time if you recognize them. And the first one is perfect square trinomials. If I have a trinomial of this form where the first term and the last term are perfect squares, then the factored form is always going to be a plus b to the second. Okay, so the pattern is the first, I don't like this color, hold on. The first and last terms are perfect squares. So what happens when you notice that the first term and the last term are both perfect squares, you can automatically come up with this as your answer and save yourself some time. The next special pattern is a difference of two perfect squares. And so if I have a difference of two perfect squares, a squared minus b squared, then the answer will end up being a plus b times a minus b. And the pattern is that both terms are perfect squares and that you're subtracting them. There's a minus sign. So again, if you notice these things, that both terms are perfect squares and that you are subtracting them, then you can automatically jump to this factored form. The last one is a trinomial with a leading coefficient of 1. So this trinomial has a leading coefficient of 1. Remember, a leading coefficient is the term with the highest exponent. So even if this a squared were in this place or this place, it's still the leading coefficient because it has the highest exponent. Okay? Whenever I have a trinomial, I draw a little graphic organizer to help me figure out the factors. So in this x, and we'll consider this our pattern, in this x, the top part is the product. Oh man, that's bad. Let me try to rewrite that. Okay, that's better. So the top part of this x represents the product, the bottom part represents the sum. You get the product from multiplying the coefficient of the first term, which in this case is a squared, and so that makes 1, times the constant in your trinomial, which in this case is 6. And 1 times 6 is 6. The sum is the middle term, the one that has only the one letter with it. So that's 5. And so now, when I go to get my answer, I know that since the first term is a squared, then the first thing in each of my factors is an a. And the other part I get from this space and this space here. So, and in those spaces I'm looking for two numbers that multiply to 6 but add to 5. So always think about your factors of 6 first. I know that the factors of 6 are 1 and 6, 2 and 3, and that's it. So out of that combination, how do I get a positive 6 when I multiply and then they also add to 5? And I know that in this case, that is the 2 and the 3. So now I take that 2 and that 3 and I write plus 2 plus 3. And that's the factored form of that trinomial. Alright, next we're just going to go through a couple examples that say when you see the directions factor completely, you need to be looking for, first of all, is there a GCF? Is there a GCF? So if there is, then you need to factor that out. So let's look at our binomial. I notice that we have a 6 and a negative 3. And out of those two numbers, I know that 3 is the biggest number that divides evenly into both of those terms. Next, remember I look at my letters. They each have an x part, and this one has the lowest exponent, so x will be part of my greatest common factor. And lastly, the y's. Each has a y being the least exponent of the two, and so y is part of our greatest common factor. So now I take that greatest common factor, divide it into each term, And so remember to write it on the outside for your answer. If you don't write the greatest common factor down, then you haven't given me the factored form. So in our first term, 6 divided by 3 gives me 2, and the x and the y are going to be gone. In the second term, negative 3 divided by positive 3 gives me negative 1. And then my x squared over x becomes x, and y squared over y becomes y. And remember, it's not necessary to write this 1 here, but if you do, that's okay too. After you've looked at the greatest, or taken out the greatest common factor if there is one, the second step is to see, can I factor what's left in parentheses? And if you can factor what's left in here, then that's what you do. Either using the x that we just learned about, or some other method that we'll talk about also. And I noticed that nothing in here will factor, so this is the factored form of the binomial that I started with. Here's another example. So first we'll look for the GCF. So looking at each of my coefficients on my terms, 7 being the smallest, does 7 go into negative 21 and positive 14? Yes, it does. So 7's part of my GCF. Do each of these terms have an x? Yes, they do. And it's just x that we'll be using. Do each of these terms have a y? This one does, this one does, this one does not, so it's not part of the greatest common factor. So now I divide each term by the 7x, remembering to write my 7x outside of the parentheses of what I'm going to have left. So dividing the first term, I'm left with y. Dividing the second term, I'm left with negative 3xy squared. And dividing the last term, I'm left with a positive 2. Now, remember we look for, can we factor what's left in the parentheses? So looking at these parentheses, a general rule is, if you have a squared term, then sometimes you can factor using the x method. But I know in this case that I cannot do that. Okay, this example is a trinomial, so I know that I'm going to first look for the GCF, and I know in this case that the biggest number that goes into all three of these terms is just 1, so I don't have to worry about that. I'm going to put none. So secondly, I try to use the x that we learned about. Okay, so I'm going to go ahead and get my answer set up here. I know that since this first term is x squared, in my parentheses the first term is going to be x. And so now I go to my graphic organizer where the product is at the top, the sum is at the bottom. Now to get this product on the top, I take the coefficient of the first term and the constant, and that would be 1 times 9, which gives me 9. And the sum is the middle term that is left, which is a positive 6. So now, thinking about the factors of 9, I know that there are 1 and 9, and 3 and 3. So, choosing out of those two sets of factors, I know that the ones that are going to work are 3 and 3, because 3 times 3 is 9, but 3 plus 3 is 6. So when I go to write my answer, it will be x plus 3 and x plus 3 in this case. Now this particular trinomial happens to have the same two factors, x plus 3, x plus 3. So you might see this answer written as x plus 3 to the power of 2. The next one I'm going to apply my rule of a perfect square trinomial, because I noticed that this term and this term are both perfect squares, which was one of our first rules. And actually we could have applied that with the previous example. So because of that, I know that my answer is going to be, x minus 5y to the second. And the reason this time that this is minus is because my middle term is minus. And the only way to get a negative 10 is to add two negative 5s together. Now, if you don't remember the rule, it's okay. You can always apply the graphic organizer x, whether you have the product and the sum, to come up with that same answer, just like I showed you on the previous example. Now, sometimes you get polynomials that have no greatest common factor, and you can't make any other method work. The x method won't work. It's not a difference of perfect squares or anything like that. And when it happens, sometimes those don't factor, and we consider those to be prime, because the only factors of them are 1 and the polynomial itself. So for example, if I had the trinomial x squared plus 3x minus 5, and I was trying to use this organizer on it, that would mean I need a product of negative 5 and a sum of 3. So I know my factors of negative 5 are negative 1 and 5, are positive 1 and negative 5. Neither one of those combinations will give me a positive 3 when I add it. Therefore, this trinomial would be prime. Now, here are just a few problems you can try on your own before you come to class tomorrow, and that will help us get started on the assignment and help see where you might need help before we even begin. I will tell you that the bottom two have GCF that you need to take out before you do anything else. Don't stay up too late so it's not that hard to wake up.